All right, on today's episode of Python Papi, we're back inside our TensorFlow course and we're still doing our malaria training coordinates module. Let's have a look at what we went over today. Now, yesterday, if you recall, we didn't have any hiccups. We were just moving really, really slow with compiling our information or our training model. So I actually went ahead earlier and started compiling it. Now, initially, it was supposed to be 100 epics that we were supposed to train our model on. That would have taken days or weeks maybe with the way it was moving. So I just dropped it down to three just to give you an example. I actually printed them out here, but I still have it compiled. I didn't clear my screen yet, so we can go over some things today. So first and foremost, we're gonna our first output was this one here. You notice that we have a loss of 0.0015 with a value loss of 3.6434 for our first epic. Now you can see the major difference there in the two numbers here. The values aren't supposed to be that far apart. So this was the first epic that our training model ran, and it's supposed to get better as they go. As you can see, the second one was a 2.1 for the loss, and the value loss was a 1.2. So it is getting closer. And let me see if I can find out a third one. Sorry about that. 1 second. Yeah, you can see our third one here. Our third epic was a 9.0, and the value loss was a 6.3. So it is getting better little by little. Like I said, the training model is supposed to be trained on 100 epics, not three. So this is just still the tip of the iceberg. Still the tip of the iceberg with the training model. It's supposed to have a lot more training to do, but like I said, it would have taken forever. So I just dropped it down to three for demonstration purposes. And also, the numbers are probably so skewed because we're using a regular model or a standard model to train our model on. And we're going to be using this one next, the Lynette model, to train next to see if there's a big difference. Because the instructor did use the Lynette model on his also. So I want to use the Lynette model to see exactly what's going on with that and if there is the big difference. Initially, we just had it like this. The regular model, how we compiled everything, how we summarized everything, and how we ran everything. But now we're going to be using the Lynette model to run everything and compare those numbers. And if you don't recall what the Lynette model actually is, let's have a look and see really quickly. So if you can see here, but with the CNN or the convolutional neural network, to be specific, what we would do initially is just initialize these values and we will let the model do training to learn these values automatically. So these values are learned by the model during training automatically. One of the very first CNNs or covenants was built by Jan LeCun in 1989, and this is the structure of the covenant known as the Lynette. And this Lynette takes an image. So that's why we're using the Lynette model here, because as you recall, we're using images in this training model to tell us if our images of our cells are parasitized or uninfected. So that's why we're using the Lynette model, because that model is specifically geared towards going towards images. So yeah, so these original three epics, which were supposed to be 100, we're training using the regular standard model, but now we're going to use the Lynette model for the next three. I'm not going to change it back to 100 because it's still using the CPU, so it's still going to take forever. But this time we're going to use the Lynette model because it's geared more specifically for using images. So that's where we at now. I could have bypassed this. It's going to be a slow crawl for the next few days in the TensorFlow. I was debating on bypassing these last few steps, but we're almost at the end of this module. So I figured I'll just go ahead and crawl through the last few steps. It's going to take a while to get through because of the compilation, but I'm going to go ahead and crawl through it so we can get a handle on everything and we can get a visualization of everything and see exactly what's doing what. So yeah, that's pretty much where we are. So that's done now. And I can actually start compiling this now, because if I start compiling it now, it'll be ready by tomorrow. I wish I was joking, but yeah. So we changed everything to the Lynette model. So yeah, these three right here, as you can see, the numbers are wildly different. You have the 0.0015 as the loss, and then the value loss is a 3.6. So we're going to see if using the Lynette model is a big difference, because like I said for the third time, the Lynette model is geared more towards images, which we are using in this training model. So yeah, that's where we at with that. Of course, I did do more. I did do math. Of course, like I said, I'm gonna do math every day. Every day that I do my courses, I'm going to do math so I can move hand in hand and we can have everything moving together. Today we went over, let me see if I can go down to where we left off at. Today we went over Jacobian chain rules. So that's where we at right now inside of our math. why was I say math module inside of our math course. And yeah, so that's where we're gonna pick that up tomorrow. Like I said, I'm not going over the math course. I'm just gonna keep you updated on the progress I'm making in it. So yeah, but that's what yesterday we did Jacobians. On the first day we did gradients, and today we're doing Jacobian chain rules. So yeah, that's where we're at with that. So yeah, let me see if it started compiling. I can actually it hasn't started compiling yet because we still have to go through everything with this. So yeah, I'm going to start compiling this, and it should be ready for tomorrow, so I can show you exactly what we're working with tomorrow with the Lynette model as opposed to the regular standard model. Yep. So of course I will keep you guys posted every step of the way. But for now, this is the Python Papi. You guys stay Gucci.